There you are. Hi, my name is Patrick, but you can call me 26. And what we're going to do today is we are going to talk about the Equatable Protocol. For Swift reference types, that is usually classes, equality is evaluated using the identity equality operator, right? Which is just going to be three equal signs, right? So when you want to compare classes, you could do that. And that looks like this. So when you want to compare classes, you do that. But primarily what you're going to do is you're going to look at value types. And in particular, we're going to look at struct. So let's say you have a struct of a person, and that has a name and an age, and we can create a couple of them. We could create a couple of persons, right? Now, when you want to compare the various people, you could make it conform to equatable, and you could do that with creating an extension for the person, right? I'm going to show you the long way to do it and then the short way. So what we could do is we could come here and do this. And this one just tells it that you can compare one person with the other, right? Now, the next thing we could do is we could come here and we say Mark is going to be Mark, and this is going to be evaluated to true. You see, even the trying to suggest that it's true. And then if we also come here and we say Mark is going to be John, this is also going to be evaluated to be false. When you actually run the code, you'll find that it's false, right? So that is that, right? Now we could save ourselves having to do this by just coming here and making sure that the person conforms to equatable, right? So if we say person struct conforms to equatable, run this, we do get the same code. True, false, right? Works exactly the same. And now we can actually make functions that use the instances of the person. So for example, if we want to, we could create a function that checks which person has been passed in, and depending on that person prints something, right? For example, here we say that we have two people, Mark and John, and of course the default for the switch. So if you pass a type of person here, it's going to check whether it's Mark or John and tell you whether or not there is not a nice person. Else, you're going to return nil, right? So if you pass like Jane or Mike, right? So for example, if we come here and we say something like, if we come here and do this is going to tell us that in particular, John is not a nice person because it checks the person that you passed in here, right? Now, we also have another thing called conditional conformance. And conditional conformance is the same mechanism that provides for an array where an element is equatable to itself and conform to equatable, right? So for example, if the actual elements are conform to equatable, the entire array will conform to equatable. What that means is that we could say, if we create an array of Mark and John and check whether or not they're equal to an array of Mark and John, this should return true, right? Because you see here, Mark and John both conform to equatable. But if we do the same, right, and we just reverse it by saying John and Mark, this should give us false, right? If we come here, do this and say John and John Mark, because here it's false, because the first element is different from the second element. So this is going to be different, right? Now, another protocol you could look at is going to be comparable. You can get away with creating comparable by only adding one more comparison, right? So here we have put equatable, which tells us how we can find which two instances are equal, how we can do that with equatable. For us to compare them, all we need to do is just come here and we create an extension. So I'm just going to show you the long way of doing it. And this is going to be person, like so. And we're going to say something like do comparable, come here, do this. There's a functionality and it just needs one function. We could say static func. This is going to be this. And we're going to compare them according to the age, close them up, right? So you see here in equatable, we are putting it as equal. And then here we're putting less than. If we do this, that means that you can figure out all the others, right? Who is greater than, who is less than, who is equal to, right? Because of course we have equatable. So using equatable and the comparable protocol allows you to find everything. And to prove this, we could put them in an array and sort them. So you could come here and we say something like, let people is going to be Mark, John, Jane, and Mike, right? So because you have comparable and they conform to comparable and equatable, we could get the maximum and this will check whoever is the oldest here, which is going to be Mark. So you could come here and say something like people.sorted. So if we run this, we're going to find that the people are sorted according to their ages, and also people.min at the smallest, and just to be sure, people.max. So if we actually run all this, and it's taking a bit of time to conform or to finish, but this will allow us to actually figure out who is the minimum and also sort them. So if we check on our results and we come here and we see the array of 4 persons, right? And we check, we will find that struct, the first person is, if we check John, who is 25, the youngest, I believe, Jane, 27, Mike, 29, and the last one should be Mark, who's 30, right? And the minimum should be John, who's the youngest, and the maximum, if correct, should be Mark, right? So that is all about comparable, which works very well with equatable, right? So thank you for watching, subscribe to the channel, and I'll see you in the next video.